Okay, now we're doing relative frequency. We're going to fill something in here. Remember, we're in the section probability and data handling. We briefly spoke about the terminology, and that's going to carry on straight into what we're doing now. Okay, probability. We're going to start with theoretical probability. Right now, theoretical probability is what we've just done. It's a number between, or in the previous video, it's a number between 0 and 1, which describes how likely something is to occur. A probability of 0 means that an event will never occur. It will never happen if the probability is 0. A probability of 1 means that the event will always occur. It will happen 100% of the time. 0 is 0%, 1 is 100%. A probability of 0.5 means that the event will occur half the time, right? So it's 50%. The theoretical probability, let's go slowly through this, of an event can be calculated when all the events have an equal chance of occurring by dividing the number of outcomes in the event set, the number of outcomes that we want, by the number of possible outcomes in the sample space. Okay, what do we mean by this? The number in the sample space. If you're battling to remember what these two are, make sure you watch the previous video. Let's have a look at this. So the theoretical probability. This is, theoretical means something that should happen on paper but doesn't always happen. It's theory. It's a theory that it might happen. It's theoretical. And then we're going to look at the number of desired events and the number of possible outcomes in the sample space. Okay. So the probability of something happening is equal to the number of desired events sets divided by the total number of sets. N means simply number. What do I mean? Let's get into this. Okay. What is the theoretical, right? We're talking theoretical probability of me flipping a coin and it landing on a head. Okay. There's two possible outcomes to this experiment. The coin either lands on heads or tails. So the number of samples that we could possibly get is 2. It's either head or it's tails. There's 2 possible outcomes, right? We want the coin to land on heads. So there's only one desired event that we get, and that desired event is NE, the number of events is just 1. We only want heads. So let's plug this into our equation. We say the probability of a head, we said here now, heads. The probability of a head is equal to the number of desired events divided by the number of the sample space, and that is equal to 1/2. You see how we took those in there? And that is equal to 0.5. And that's our answer. 50%, 1/2. Remember, the probability of me flipping a coin and landing on heads is 0.5 or 50%. Now let's look at relative frequency, what this video is about. Right now, relative frequency is how often an event will occur, so how often it will happen, divided by the number of times which the experiment was done. What an experiment means, we had to do it. So relative frequency is not a theoretical thing. It's not a thing that we're guessing. It's something that we've recorded in hindsight. Only afterwards we've calculated the relative frequency. Okay, make sure you understand that. To get your relative frequency, you must repeat your experiment a number of times and record the number of times you got your desired outcome. So you must repeat your experiment. Relative frequency we're going to give as an F. Frequency is an F. It's a ratio between the number of times you received your desired results, so we're going to call that a P, the number of times you received it, and the number of trials or experiments which were performed, and we call that T for trials. Okay, so we're going to take those variables and we're going to say the frequency is how many times we got what we wanted divided by the total amount of times we did it. Okay, and that's the formula we're going to do now. The theoretical probability is calculated without actually doing the experiment, and the relative frequency can only be calculated using the results of an experiment. Okay, remember, relative frequency is relative to an experiment. Let's go into an example. What is the relative frequency of me flipping a coin 10 times and it landing on a heads? The only way to do this is to actually sit at home and flip a coin 10 times. So I want you to do that. Go and get a coin and flip a coin 10 times. I'm going to show you a table that you can draw and fill out. So you've got to flip that coin 10 times. We've got to record the number of times the coin is going to land on the heads. Now we're going to pretend in this video that we've flipped it 10 times, and the results are the following. So I want you to draw this table at home right now. You're going to do 10 examples and you're going to see your results. You flipped it the first time, we get a heads. You might get something else. Then we get a heads, a tails, a tails, 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 heads, tails, tails, heads. Okay, so you can see we've got 1 head, 2 head, 3 head, 4 head, and then 6 tails. So the relative frequency is counting the number of times which the coin landed on the heads. Right, this is our desired outcome. What was this symbol? Remember, that was P. So the coin landed on heads 4 times, so P, our desirable outcome, is equal to 4. We're going to circle that. We already know that the experiment was done 10 times, so T, the times of the trials we took, was 10. We took it 10 times, as you can see. So we're going to take that. Let's put this into our equation. Frequency equals P over T. And that is 4 over 10, and that is 0.4. And that is the same as 40% or 4 over 10, and that is our frequency. Now, if you were to calculate your theoretical frequency, you might have thought that it was 50%, right? Because your relative frequency is 0.4, it's not far off your theoretical probability of 0.5. If you did that 100 times, you'll probably get even closer to 0.5. And the more and more you do it, the closer and closer you'll get to your theoretical. But your relative will still be different, or could be different, because it's what actually happened. You could, by some absolute fluke, get all 10 on heads, and that's still okay. But it's not theoretical, it's only relative. Relative frequency is the ratio between how often the desired event happens. What is your desired event? Remember, that is P. And the number of times the experiment was done. Remember, that's your trial T. So P over T is our frequency. Remember that. Remember our previous example where we knew that the probability of an event was the number of desired outcomes over the number of possible sample spaces. Watch that video if you are confused. Now we're going to move on to Venn diagrams. Good work, grade 10s. Keep it up.